Hello, dear participants. Today I'll be talking about the study titled Structural Effects of Amine-based Chain Expander on the Surface Properties and Scratch Profile of Polyurethane-urea Coatings, which is a side study of my PhD thesis, and we are still working on. First of all, I would like to make a brief introduction. The economic and ecological importance of the coatings which protect and prolong the lifetime of the products is enormous. Organic coatings, including acrylic resins, polyphenols, epoxies, and polyurethane, have been widely used in different industries. Additionally, organic coatings can provide many improved surface properties, such as easy to clean, scratch resistance, and anti-fingerprint. If we focus on polyurethane coatings here, they are known to have excellent wear resistance, chemical resistance, and mechanical properties. They are widely utilized in furniture coatings, metal corrosion protection, electronic device protection, and other sectors due to their outstanding features. And polyurethanes can be prepared with a wide variety of components, so materials with the desired properties can be produced with a different combination of these options. Polyols are one of the main components of the polyurethane coatings, and the isocyanates are reactive compounds containing NCO groups, and they react with polyols to form to polyurethane. And also solvents are often added to the polyurethane coating to adjust the viscosity and improve application properties. And here, chain expanders are amine or hydroxyl terminated that react with the polyisocyanates to increase the volume of the hard segments and improve the final properties of the polyurethane coatings. And the numerous possibilities to combining chain expander with polyisocyanates contribute to the broad applicability of polyurethane and polyurea coatings. Chain expanders are low molecular weight multifunctional compounds that react with the NCO groups of the isocyanates. They play an important role in the molecular structure of the polyurethane coatings. And polyurethane coatings without a chain expander formed by directly reacting polyol and isocyanates generally have very poor physical properties. When the diol chain expanders react with the NCO groups, yield urethane bonds, and when diamine chain expanders react with the isocyanates, form urea bonds, and diamine chain expanders are much more reactive than the diol chain expander and give better properties than to others. The isocyanate groups in the polyurethane urea structure are highly reactive and can undergo a reaction with moisture present in air. And the moisture reacts with the isocyanate group to form urea linkages. And this process leads to the cross-linking of the polymer chains and formation of three-dimensional network structure. In our study here, we have two different formulations other than the base coating. Our first formulation is our base polyurethane coating formulation that does not contain any chain expander, only contains main components of the polyurethane. And we coat it on metal surfaces in the spin coater device and cure it oven at 130 degrees Celsius. In other two formulations, we also add chain extenders in the step where we add to isocyanate to the solution. We use aromatic paraphenyldiamine and cyclic aliphatic piperazine compounds as chain extender. Thus, we will examine the effect of compounds with different structure on the coatings. We coat the formulation containing chain extender on metal surface in spin coater device same way, But this time, coatings cure quickly under the room temperature, even if after the application. And as you can see in the GIF, we cure the coatings without any external heat source. When we look at the FTR analysis, we can see the characteristic peaks, and the carbonyl bonds were found to shift lower wave numbers due to the intermolecular or intramolecular hydrogen bonding. And our work on FTR analysis and interpretation of peaks continues. In SEM image, the surface of the diamine chain extended polyurethane coating were homogeneous and smooth, whereas the blank polyurethane coating had a wrinkled appearance. The piperazine sample has not yet been analyzed. An increased surface roughness of the coating causes diffused reflection of light and resulting reduced gloss. We can see these results, but all the obtained value is high enough to classify the coatings as a gloss coatings. And here in the table, phenyldiamine chain extended sample is more darker color tone than the blank polyurethane sample. This may be the reason blank polyurethane solution is colorless, clear liquid, and the brownish color was attributed to the effect of the phenyldiamine chain extender. The only sample that failed in adhesion test was that one containing piperazine. This may be due to the its low degree of cross-linking, as I said before, and hydrogen bonds are relatively strong intermolecular forces. In their absence, the interaction between the coating and the substrate may rely on weaker forces. And when hydrogen bonding is lacking, the overall surface energy may decrease and potentially leading a poor wetting and spreading on the coating substrate. Flexibility and deformation resistance tests here are not quantitative and give qualitative indication about the hardness and toughness of the system. All the samples pass these tests. Generally, a highly cross-linked film may exhibit improved scratch resistance, but it's less flexible and much more sensitive to cracking. And although we saw a visible scratch under 0.1 Newton load both samples, we observed a more visible and wider opening in the scratch and applied to the coating containing phenyldiamine, since it's sensitive to cracking. In the coating containing piperazine chain extender, the cross-linking is more than the blank one, but less than the diamine one, so the scratches are a medium depth. Last of all, we have successfully synthesized polyurethane coatings containing chain extender, and as a result of the test, we observed that when we use diamine chain extender, thermal stability increased and smooth morphology was observed. And in addition, we think that the moisture cured coatings, which are frequently used in high performance coatings, are promising in terms of energy saving because they eliminate the energy required to cure the coatings. And additionally, because of this study is ongoing, characterizations continue. Lastly, I will thank to Scientific and Technical Research Council of Turkey, Istanbul Technical University, and Arçelik. And thank you for listening.